You are welcome to Joe Newton online class. In this particular class, we want to look at echo, which is a topic or a subtopic under sound in physics. Now, before we tackle the task on the board as illustrated, what do we mean by an echo? An echo is a sound heard as a result of reflection of sound on a hard or plane surface. That is an echo. So we have applications of echoes as well. We can apply echo in detection of submarine, also in mineral exploration. You can use devices that have echo system. We can also apply echo in determination of the speed of sound in air using the conventional method and the principle and formula. So these are some of the applications of what? Echo. Even we can also apply echo in the submarine detections, like I said earlier. So there are many, even in sonar systems, that is sound devices, we use echo. So without wasting time, let's look at the illustration task on the board. Now, look at this. This diagram illustrates a boy pictorially, a boy that makes a sound, perhaps class or beats a drum, and this is a hard or plane surface. Now, this boy hears the sound maybe 0.5 seconds after reflection on this plane surface. Then, if the speed of sound in air is given as 340 meters per second, we are now asked to find the distance between the boy and the plane surface or the wall. Okay, in solving this, we say that we use the equation. Of course, we know that generally speed is distance over time. Generally, we know that generally V equals to S over T. But for echo, it is not the same. Generally, speed is equal to distance over time. Or you can use D as the case may be, or V equals to D over T. Distance over time. But in the case of echo, the distance is doubled. That is the clarification I want to make in this class. Some students make that mistake. In the case of echo sounding, the distance is doubled. That is, the distance is twice because the sound travels and hits a plane surface covering the same distance, and it takes the same distance for the sound to come back to the source. That is it, or to the producer. So that to and fro movement of the sound wave there makes the distance double. So the distance from the producer of the sound to the plane surface, that is the reflector, and from that reflector back to the producer makes the distance twice. So in the case of echo, we have that V is equal to 2D over T. So the distance is doubled in the case of echo. For echo to be heard, the distance must have been covered twice by the sound. So following this formula now, our V is given as 340 meters per second, and our time is 0.5 seconds. So we now, for distance, we can now say that cross multiply here, you have that 2D is equal to V times T, such that D is equal to V times T over 2, which is equal to, our V is 340, our time is 0.5 over 2. Now, having this on board, 340 times 0.5 will, of course, give us, it is like saying half times 340, half of 340, because 0.5 is half. So half of 340 is 170 over 2. So our distance is equal to 85 meters, because 170 divided by 2 is what? 85. So the distance between the boy who makes the sound and the plane surface where that acts as the reflector of the echo is what? 85 meters. Thank you for paying attention to this class. For more of these solutions in physics and mathematics, you visit my YouTube channel. There you will like, subscribe for notifications each time I upload videos, and also share. Join me and follow me on my Facebook page as well at Joe Newton Online Class. Thank you and God.